All right, so we're going to start off with the second U-try problem from our notes. If you haven't tried it already, you don't need to keep watching this video. You can try it, pause the video, come back, and I'll show you the solution. Okay, so if we graph negative 2x plus 5, what does that look like, right? So we need to go up to our y-intercept of 5, down 2 and over 1, down 2 and over 1, so on and so forth. So we're going to do our best here with the stylus, but that's pretty much what we're looking at. And then we're going to do the same thing for 2x squared plus 1. Now this one has a vertex of 0, 1, so that's helpful. And then if we were to plug in another point, let's say 1, we would happen to get 3, which is actually in line with our line that we just graphed. And because of mirror images, we know we'd have to look something like that. So again, if we're solving this thing by graphing, not as easy, right, to see what these solutions might be. One of them is definitely 1, 3. And it just so happens that this other one over here is negative 2, 9. So again, we see that there are benefits to graphing just from the visual perspective, but in terms of the solution itself might not be as convenient. But negative 2, 9 and 1, 3 would be our solutions. Okay, so the next U-try, number 3, has you look at two different systems and you're solving those by substitution. So again, let's take a look at those. If you want to pause the video, do them yourself, you can. And we'll come back and we'll do the solutions. Alrighty, so substitution basically indicates to us that if you have y equals, then we should be able to set those two things equal to each other. So that's exactly what we're going to do. We're going to say x squared minus 6x plus 10 must equal 4 minus x. We're going to swing everything over here so we could set this equal to 0 and see what kind of options we have for solving the quadratic. So that gives us x squared minus 5x plus 6 equals 0. Looks like this is factorable, so that's a good thing. Simple, don't have to use completing the square or quadratic formula, it's a little quicker. So we get two solutions, right? X equals 3, x equals 2, and we do want to follow through here and find out what the actual coordinate of the solution is, right? So I think you just got to pick your battles here, and I think you want to probably plug these values back into this second equation. It's a little easier. So we find out that y equals either 1 or y equals 2. So 3, 1 is the solution, and 2, 2. Okay, next one, very similar. The only thing we want to do is we probably want to get ourselves to that y equals spot. So y equals 12x plus 30, right, before we go ahead and set these things equal to each other. So x squared plus 11x minus 12 equals 12x plus 30. Again, let's see where this takes us. X squared minus x minus 42 equals 0. Looks like x minus 7, x plus 6. So we finish up with x equals 7, x equals negative 6. Let's go get those y coordinates, right? So it looks like 7, and that's a pretty big number. Looks like 7 and 114 is one solution. Imagine trying to graph that, right? And negative 6, negative 42. So this is why substitution sometimes is our better option. All right, so that brings us to the last problem, which is just an application, right? We have some information about the attendance at pool A versus pool B, right? And they'd like to know in part A, on what day, right, X is days, was the attendance the same at both pools? So basically, when is 28x plus 4 equal to negative x squared plus 39x plus 64? And again, your choice, you can graph it, or you can use substitution here, right, which is what I think I'm going to do. Now, in this case, I don't want this negative x squared, so I think in this case I'm moving everything over to the left here. So we're going to have x squared, right, minus 11x, and it looks like minus 60. So think about that. What factors of 60 am I going to work with here? X minus 15, x plus 4. So mathematically, yes, our answers are 15 and -4, but we have to go ahead and throw out -4. It doesn't make sense because X is days since opening day, so we can't be talking about days before opening day. So it looks like the attendance was the same 15 days after the pools opened. And then, of course, the second part B, says, well, what was that attendance? So how about we just use the first equation, y equals 28 times 15 plus 4. And that looks like that gets us 424. So 15 days after opening, the attendance at both pools is 424 people. Okay, so at this point you want to get out of the video part of it and start working on the 5-4 homework that's attached to the notes. And of course we can go over any questions you have next time we meet.